Hello everyone. Today we'll be talking about distributed databases. So we've been talking about relationship database management systems, and those typically are installed on a single machine, usually some good machine with good hardware, probably a data center machine that is able to run a database, and it usually a designated server that only runs the database. In certain situations, however, single machine is unable to handle the volume or the load of requests, and in that situation, it is necessary to go to distributed database management system, and in certain situations it is necessary also to have the databases themselves to be distributed. So there are several sites that would maintain database, and they are connected through a network, and there is a database management system that is able to combine those databases in multiple locations and handle the disk access, the updates, the retrieval and updating of tables in distributed fashion. So the distributed database management system is a software system that permits distributed databases and makes the distribution transparent to users. So to make transparent to users, it means that the users are not concerned with the fact that the databases are located physically in different locations and that the database management system is accessing those remotely, but it seems to the user as one regular normal database. So this is what happens with the distributed system. There is a collection of logically shared data. The data is split into sections or fragments. For redundancy, the fragments may be replicated. When we have a database management system, usually the files, the data, tables that we have are replicated at least 3 times to make sure that we are resilient in a time of failure. If any of the disks fail, if data is lost, then we have 2 backups to recover from at least. And this is the same situations, although that the data files may be stored in multiple locations, we still keep at least 3 copies of them, and each one could be at a different site. Usually we use the closest site. Then the sites are linked by communication network, and the data at each site is connected to the database management system, and it is controlled by the database distributed database management system. On each site or location, which means each individual computer or machine, the local applications will run autonomously, and each local database management system participates in at least one global application. So we have a collection of shared data. The data is split into pieces. Each piece could be the pieces are replicated at least 3 times. they might be allocated to different sites. The sites are linked by a network. And the remote sites are managed by the distributed database management system. So this is what it looks like. LDBMS is the local site, the local management system. So this is what you see here. Local database management system. DC data communication components. So that's right here. Let's make this green. And then we have GDD, Global Data Dictionary. So our data is split into multiple sites in this situation. Those round looking things are the disks of the remote machines, and that is the Global Data Dictionary. So Global Data Dictionary means that all the remote sites speak the same language, they can understand each other, and they that is dictionary for storing and retrieving the data, updating and creating tables. All these sites understand each other, they speak the same language. That is, there is a distributed database management system, which is like a distributed operating system that is able to connect the disks of multiple machines together to access their files. There is a centralized location where it knows all the databases and disks that are part of this system, and where they're located and how to access them, and makes that transparent to the user, so that to the user it appears that it's one regular database. However, there are multiple sites and they are connected to the network. So each site will speak the distributed language, will have its database tables, and the others can access them remotely through the network. As we mentioned, data can be divided into pieces and stored at multiple sites. Each piece would be replicated at least 3 times, so that we can recover from crashes or failures, or if one of those sites goes down, then the closest site which has copy of the required data will take over, so that we are able to recover in the face of failures. So when we create a database application in this distributed scenario, it should be able to operate able to operate on using the multiple sites. So the application can be spread across the different sites. It can run on different machines, and it is supported by a variety of operating systems. this is the idea of what we would like to have. So that's the ideal situation. And then it should be able to connect through the communication networks that exist. The sites can physically or geographically be located far distances if necessary. So the distributed database systems would be is a collection of database sites that is connected via the communication network in each site. We have the database system, and the sites are working together. The users can access any site data that is anywhere on those sites. So this is pretty much like a partnership amongst the local database management systems. And that are being accessed remotely. So we have site 1, site 2, site 3, site 4. Each of those has a machine and a database stored on it. It has local database management system. However, as a whole, there is the distributed database management system, kind of like a distributed operating system that knows where each site is and what data is stored in its local drives, how much free space we have there, what processors are available for running queries and updating the data, and so on. There is a centralized location that has, it's like the master node that has the information about all the participating nodes of or sites of this distributed database management system. To the user, like we said, it looks like one single system. It's the distributed setup is transparent to the users. And they are connected through the network, which is what we see here right in the middle. So let's see a little bit about parallel database management systems. So the database management system can run across multiple processors. And disks. That are designed to execute operations in parallel. If that is possible, it would significantly improve the performance. So this means if 2 or 3 queries come in together, if the queries are not related to each other, we could have each one being processed on a separate processor at the same time in parallel. And that would have a significant improvement on performance. So that has to do with cost effectiveness, reliability, and performance. So this kind of parallel systems would link multiple smaller machines to achieve same throughput as a single larger machine. However, we have greater scalability and reliability in this case. So for the parallel systems, we would be sharing the memory of the machine, the disk. We can configure it of what we would like to share from it. So first one is sharing the CPU, second one is sharing both the CPU and the memory, and the databases are here. They're connected through the network. In the third scenario, we have same situations sharing CPU and memory, but through a different topology. Over here, they were all connected in a single line, and here we have some above and some below the network line. So topology means different geographical setup in the location, the physical location of where the machines are with their CPU and memories. So what are the advantages of using distributed database management systems over a single system? The advantage will be improved availability, because if a single system is not available, that its system is being updated or it's having some performance issue, then another system can take over while the first one updates. Or improved reliability, same thing. If one of the systems fails, let's say it is crashed or it is physically destroyed, or the disk has gone lost some data, then another site can take over that has the replicas or multiple copies of the data. So we have improved availability, reliability, and improved performance. If we're having parallel systems, we're able to a database system, we're able to execute multiple queries on different processors at the same time, so performance is improved. Economics need to be considered. The cost of the systems, is it more economically cheaper to buy one big machine or to have several small machines? And another advantage is the modular growth. That is, we divide the data into modules or pieces, and think how we can improve or advance each of the pieces. Now, there are other factors that need to be considered in the distributed environment. Of course, it is a more complex system than the single system. Then we need to consider how we will implement the security on the distributed system. So there are going to be multiple sites. Users need to be user access. Access control lists, so the logins of the users to the remote sites. Permissions, nights, and then the actual physical security of the data. the integrity control would be a little bit more complex. As a whole, the design of this database is more complex because it's distributed, it has multiple sites. They need to go through a network. So the network itself could introduce some delays in accessing the data. Alright, if we have to go through a network to access the data, it could take longer time than if the data is on the same machine. So this is about the distributed database systems. Overall, they are more advantageous than a single system because they are more robust in the face of failure, and they allow for bigger data processing. Multiple machines can handle much larger data in parallel than a single machine. So that is what we have for the distributed database systems.